Hey everyone, welcome to today's video. In today's video we'll be seeing how we can convert an image into a cartoon image by using Python. So I'll be using OpenCV to convert this image into a cartoon image through the code which we'll be writing. So let's start by writing the code. The first thing which I'll be doing is I'll be importing CV2. So I have installed OpenCV by using the command pip install opencv-contrib-python. So this will be installing the best version of OpenCV for you. Next I'll be importing numpy as np, and we'll be using this as well inside our the thing which we are making. Next I'll make a function named as read file. So this function will be for reading the file. I'll pass a file name to it, and inside it I'll be having a variable name as image, and we'll be using cv2 dot imread for reading the image. We'll be passing the file name into it. So the file name is aa.jpeg, and after it we'll be using cv2 dot imshow. So it takes two arguments. The first one is an empty string, the second one is an image. So if you are using Google Colab or Google Codelab for this, then you can use cv2 underscore imshow, and you can skip this empty string. And at last we'll be returning this img which we have read. Sorry for this typo. Return img. So it will be returning this img. We'll be having another function which is named as color quantization. So why this function is being used? So as you may have seen that our general photo has various different types of colors, like the number of colors range from high to low, and various different colors are there. But when we are using this function, or when we are trying to create an image or a poster out of it, so a color poster out of it, so it generally has a very less number of colors which are present in it. You can consider the example of a drawing and of an image, like a difference between the colors which are present on them. So we are using this function to reduce the value of colors which are our poster or our cartoon image which will be having. So we'll be taking a variable named as data. We'll be using k-means clustering for doing this particular thing. So I'll be using float 32 over here and passing the image which we have read, and then we'll be reshaping the image. So we need to pass it in the form of a tuple -1, 3, and after that we'll be passing the criteria for it. The criteria will be equals to cv2 dot term criteria eps, and plus cv2 dot term criteria max, I guess, dot term underscore criteria max etr, comma 20, and after this what we need to pass is 0.001, and we need to pass we'll be getting the criteria. So for determining the criteria, like how we want to reduce all these colors, so we will be getting that criteria out of it. Now next thing which we want after this is we'll be having three variables defined which will be named as ret, label and center. So let me define this: ret, label and center, and we'll be using cv2 dot k-means. I need to add a 2 here. cv2 dot k-means, and it takes various different values. The first thing it will be taking is a data. Next, the value of k will be passing or assigning the value of k later on. The third thing it takes is the best label, so we don't want to pass anything, so we are adding a none. Next thing is the criteria, so we have assigned a criteria above. After this we need to assign the attempt, so we'll be passing 10, and we need to assign the these centers as well. So we'll be having cv2 dot random, I guess it needs to be k-means random centers. So it will be taking all the random centers. Next we'll be having a variable named as center, so we'll be reassigning the value of the center which we had above, and we'll be reassigning it to np.uint8. We'll be converting it into the form of uint8, uint.uint8, and then we'll be passing the center which we had above. After this, we'll be doing the we'll be having a variable named as result for this. We'll be flattening this, label.flatten. I guess I'm doing it correct. We'll have flattened the labeled image which we have got above, and the next thing which we'll be doing is we'll be reshaping the image again. So result.reshape, and we'll be passing the shape of image.shape here, img.shape here, and at last we need to return this result. Also, we need to make another function named as edge mask for adding a mask over the function or over the edges of the image. So this will be like creating a sketch out of all the image which we have passed. So creating that function edge mask, it will be taking the image which we are having, the line size. So we can we can pass the line size according to us, the blur value, and after it we'll be having the gray variable which will be converting CV to color. So it will be converting the image from colorful to gray, cv2.cvt color. So this cvt color function is used for converting the image, and we are passing the image and cv2.bgr and I guess cv2.color bgr to gray. This will be converting the image to gray. Now assigning creating a variable named as gray blur, and we'll be passing cv2.median blur, and we'll be passing the grayed image which we had above, and we'll be passing the blur value which we got inside this function. Next we'll be generating the edges. So the edges will be equal to cv2.adaptive, it needs to be adaptive threshold. So we'll be passing the threshold from it, and we'll be having gray blurred image value for the maximum value. So the maximum value of the color can be 255, and after this we need to pass cv2.adaptive thresh mean. So cv2.adaptive thresh mean C, and cv2.thresh binary line size and the blur value. cv2.thresh binary line size and the blur value. Next we can return these edges. One more thing which I missed over here is that we need to add a wait key, cv2. So that the image which is being displayed can wait for a keystroke to disappear. So this will be doing that thing. The next thing which I'll be doing is I'll be assigning the img variable, img equals to read file, and we'll be passing a file name aa.jpeg. Next we'll be assigning the line size value and the blur value, and the blur value equals to 7 as well, and we'll be getting the edges out of the edge mask function, and we'll be passing all the values to it. So the first thing will be img line size and blur value, cv2.imshow empty string, and the edges image which we have got. and cv2 dot weight key, passing a 0, edges eds here, and after this we'll be getting an edged image. Now we need to assign the total value of colors which we want, so I am passing total color equals to 9, and we'll be getting, or we'll be reassigning the image variable to color quantization, and we'll be passing the image and total color into it. We'll be showing it cv2 dot imshow empty string and the image which we want to show, and at last we'll be showing the blurred image, and then we'll be showing the final image. So the blurred image will be obtained by I'm assigning another variable blurred to cv2 dot bilateral filtrate, and inside it I am passing image value of d equals to 7, the sigma color equals to 200, the sigma space value will be set to 200 as well, and then I am showing this image cv2 dot imshow, and after it passing empty string and the blurred image which we are having, and at last we'll be performing a bitwise AND operator to get the cartoon image, assigning cartoon image inside it cv2 dot bitwise AND the blurred image which we had above, and we'll be passing the blurred image again, and then we'll be passing the mask equals to edges. Next showing it, passing an empty string over here, and we want to show the cartoon image, adding cv2 dot weight key with the value of 0, pasting it over here, here it is already present. I guess all things are fine. Let's try run this. So I guess now you are able to see the image which we are having inside, or which is being read from the image which we are having. So this is the image which will be converted to the cartoon image. Now when I am pressing a key, so you can see that this is the image which is being generated by this where it is. So yeah, this is the image which is being generated by this edge mask function. So it is showing us with all the edges which are available inside this image, and it has removed all the colors. So we are only able to see the edges from an image. Now when I am pressing a key, so it is giving me an error that flatter function is not there. So I guess I need to add flatten in place of it. Yeah, so I have made a typo over here. Saving it again, running it. So this is the image which is being showed when the image is read. This is the image of the edges. This is the blurred image which is being showed. So you can see that after this image quantization, it has removed most of the colors, and only 9 colors are available in this particular image. So this is the image which is being showed. Now let's see the image which is being showed after combining the blurred image and this. So this is the image which is being converted, or the final output which we are getting after the image has been converted into a cartoon type image. So this is how you can convert your regular image into a cartoon image with the help of Python. So that was it for this particular video. Thanks for watching.